Alright, today we're going to be looking at the product and quotient rule. And at the start, we're going to go back to page 5 where we left out those couple of rules. And we're going to fill them in. Okay, so our product rule, and this is on your formula sheet as well as our quotient rule. So the product rule is U dashed V plus V dashed U. Or, on your formula sheet it looks like this, du by dx times v plus dv by dx times u. And we'll go through what all of those things are, okay? Our quotient rule is u dashed v minus v dashed u over v squared. And on your formula sheet it's du by dx multiplied by v minus dv by dx multiplied by u over v squared. Okay, don't get freaked out by all the u's and v's. It is not too bad to do. Okay, let's have a look at how this works. Okay. Product means multiplication. So if I am multiplying two functions that have both got x's in them, alright, so you will notice I'm multiplying 3x take 1 by x squared plus 4x plus 3. Now, I could have expanded this and then done normal derivatives like we learned before, and that's fine, but what about if this thing was to the power of 5 or 6? Okay, it can get really complicated there. So this is a really simple example, but the main thing I want you to see is that I'm multiplying two functions that both have got x inside them. And the way I'm going to do that is I'm going to say using the product rule. And we always refer to the rule we're using. There are marks allocated to that in the exam. And I'm going to let u equal my first one, 3x take 1. And I'm going to let v equal x squared plus 4x plus 3. Now I want to find my derivative of u. So I'm going to write u dashed. And our derivative of 3x take 1 is just 3. And my derivative of v is going to be 2x plus 4. I now have got all of the information I need in order to find my product rule. So I'm going to write y dashed equals u dashed v plus v dashed u. And that means I'm going to have, well, u dashed is 3, so it's going to be 3 multiplied by my original v, so x squared plus 4x plus 3. And then I'm going to go plus v dashed, which is 2x plus 4, and that's multiplied by u, which is 3x take 1. And I'm going to expand that, so 3x squared plus 12x plus 9 plus 6x squared minus 2x plus 12x minus 4. And when I have simplified those, I get 9x squared plus 22x plus 5. It's an x. So therefore, y dashed is equal to 9x squared plus 22x plus 5. Alright, let's have a look at the quotient rule. Now the word quotient always refers to division. Alright, so look here, I'm dividing two different functions and both of them have got x in them. So when I'm doing that, I can say using the quotient rule. And I'm going to make u my numerator and v my denominator. So let u equal 3 take x, and let v equal x squared plus 4x. Alright, so my u dashed, now be careful with the signs. My x has got a power of 1, so u dashed is negative 1. And v dashed is going to be 2x plus 4. Again, I've got all the information I need to be able to find my derivative. So u dashed is equal to, y dashed is equal to u dashed v minus v dashed u over v squared. And I'm just going to put all those values in. So u dashed is negative 1 times x squared plus 4x be careful with your signs with this one, because often you've got negatives in your derivatives as well. 2x plus 4 times 3 minus x. And often you get a very long vinculum with these. And v squared is x squared plus 4x all squared. Alright, so we have negative x squared, take 4x, plus 6x minus 2x squared, plus 12 minus 4x, all over x squared plus 4x all squared. And let's simplify that to x squared minus 6x minus 12 over x squared plus 4x all squared. We're going to leave the denominator probably as it is, just leaving it unexpanded. You could have expanded it, but it's not going to make any difference to the final question or the answer. So in this case, we can leave it unexpanded. If we could factorize something out in our numerator, that's what we would do. Okay. All right. The sides of a rectangle in millimeters are varying with respect to time. So this rectangle is getting larger or smaller with respect to time. State the function that expresses the area of the rectangle at any time t. So let's define our variables. So we're going to let the length equal 3t plus 8 and our width be t squared plus 2. Now we all know that the area of a rectangle is length times width. So that's going to be 3t plus 8 multiplied by t squared plus 2. That's my function that is giving me the area of our rectangle at any time t. Okay, now it says calculate the rate of change of area. So as soon as we've got rate of change, we are talking about derivatives. So we're going to say, well, dA by dt is the rate of change of area with respect to time. Okay, and notice, let's put it in a different color. I have a function with respect to t multiplied by another function with respect to t. This means that I can use my product rule. So using the product rule, and we're now going to let u equal 3t plus 8, v equal t squared plus 2. U dashed will be 3, and v dashed is 2t. Alright, so we got y dashed equals u dashed v plus v dashed u, and that's going to be 3 times t squared plus 2 plus 2t times 3t plus 8, and that gives me 3t squared plus 6 squared plus 16t, and that's 9t squared plus 16t plus 6. Okay, so I've got my gradient function, or my rate of change function, but it's asking me when t equals 2 seconds, what is the rate of change of area? So I actually need to then substitute t equals 2 into that. When t equals 2, my derivative when t equals 2 is going to be 9 times 2 squared plus 16 times 2 plus 6, and that gives me 74 square meters, square millimeters squared per second. So then again we have to interpret it. So the area is increasing, it's a positive, at a rate of 74 millimeters squared per second when t equals 2 seconds.